Okay, so for number 3, so we've got this plant measuring thing where we're checking the heights of 12 randomly selected plants after 8 weeks of growth. And there's the data. It says to construct and interpret a 90% confidence interval. Okay, well, of course, we always have to communicate all of our details. Okay, so our mu in this case is the average amount of plant growth in centimeters. Okay, and then we're also going to throw in our x bar. Okay, which again, you have to throw all of this in your calculator. Okay, and then we'll do one variable. Oh, you hit stat. Go to calc, and then go to one variable stats, okay, after you've put all this in your list. So our x bar comes out to 25.5 centimeters. Our standard deviation is 2.611. Our n is 12. Our degrees of freedom is 11. So a 90% confidence interval with 11 degrees of freedom gives us a t star of 1.796. Remember, that is going to be inverse t of 90% means we're going to look at, let me draw a quick picture. We got 90 here, which means there's 10 on the outside, which means we're doing 0.05 for our area, and then degrees of freedom of 11. So you throw that in your calculator, and it gives you 1.796. All right. So then now we got to check our conditions. So random, she does randomly select the plants. Independent, we have to make sure that 12 is less than 10% of our population. So it's less than 10% of all plants of this type, which I would say is a perfectly okay safe assumption. And then normal, our n is less than 30, so we have to graph, okay? And I went with a box plot, okay, instead of a histogram like we've done a couple times in class. So here is our plant growth for this data set, okay? And I do not see any outliers, so no outliers or strong skewness. Okay, it looks pretty symmetrical to me. So here, that means we can move on for our test, okay, which is going to be, in this case, a one sample t interval for means. Okay. And our formula is, of course, x bar plus minus t star times s over square root of n. Okay. We plug in all of our information. We get 25.5 plus or minus our t star is 1.796. Times our standard deviation, 2.611, over the square root of 12. Okay, and this gives us a interval of 24.146 to 26.854. Okay, and so there is our number answer. Then we got to conclude. So we are 90% confident that the true mean amount of plant growth in centimeters will be between 24.146 centimeters and 26.854 centimeters. And there you go.